So Chapter 6, Lesson 6 is the distributive property. Okay? So in the warm-up, 3 friends went to a baseball game. Each ticket costs $20, and all 3 friends bought a baseball hat for $15 each. So number 1 says, what does the expression 3 times quantity 20 plus 15 represent? Okay? So for when we pull this apart, the 3 represents the friends. Very good. The 3 friends. The 20 represents the ticket to the game, right? Price of the ticket. And then the 15 represents the baseball hats. How much the hats cost. Very good. Okay? So here, when we want to evaluate that expression that's in problem 1, we can use our order of operations. So here, 20 plus 15, 35. And then we're going to take that 35 and multiply it times 3. Very good. So 35 times 3 is equal to 105. Very good. Now, for problem 3, let's take a look at this expression. We have 3 times 20 plus 3 times 15. Well, here, with this word problem, the 3 times 20 represents what? How much total? Right. How much total they pay for the tickets, right? And then the 3 times 15 represents how much they spend for all of the hats. And then when we add them together, we should get $105, right? So let's check it out. So here, when we do this, we're going to take the 3 times 20, we're using our order of operations. 3 times 20 is 60. Plus 3 times 15 is 45. And when we add those together, we get 105. So you see that we got the same amount. Is that clear? All right. So here, you guys, we're looking at the distributive property. Please make sure you write your heading and what the distributive property is. Here, to multiply a sum by a number, we multiply each add-in by the number on the outside of the parentheses. Okay? I also want you to write your numerical example and your algebraic example. Okay? So here we have 2 times the quantity, 7 plus 4. The distributive property says you're going to multiply each of the numbers inside the parentheses times the number on the outside of the parentheses. So we're going to multiply 2 times 7, and then we're going to add that to 2 times 4. And this distributive property will work for any numbers and variables as written in the algebraic example. All right, so the expressions 3 times quantity, 20 plus 15, and 3 times 20 plus 3 times 15 show how the distributive property combines addition and multiplication. And of course, those are the expressions that we got from our warm-up, right? So let's take a look at our first example. Here, we want to find 9 times 4 and 1/3. We want to find it mentally using the distributive property. Now, don't think that because it says find it mentally that you're not going to write anything down, okay? You're going to write down, even though you're doing it mentally, you're going to write down what's going on in your head. Is everybody clear? So you should not be leaving blanks on these kind of problems. Got it? All right. So here we have 9 times 4 and 1/3. Now you remember, way back when we were doing fractions, we learned that we can separate the mixed numbers to the whole number part and the fraction part, right? So if I split this apart, the 4 and 1/3, to 4 plus 1/3, that's going to be an equivalent expression, correct? All right. So here we're going to have 9 times, and now I'm going to split up the mixed number. 4 plus 1/3. Okay? Now we can use our distributive property by taking the number on the outside of the parentheses and multiplying it times everything on the inside of the parentheses. So 9 times 4 is 36. And 9 times 1/3 is 3. And then you can just add 36 plus 3 gives me 39. Alright, so for these guys, we have 5 times 2 3/5. Once again, we're going to find it mentally, but we're going to write down what's going on in our head. Okay? So, here we have 5 times, and now we're going to split up the 2 3/5. Okay? So the 2 3/5, we can split up to 2 plus 3/5. Okay? So now we can take that 5 and multiply it times everything inside the parentheses. So here we've got the 5 times the 2 and the 5 times the 3/5. So 5 times 2 is 10, good, plus 5 times 3/5 is 3. So now 10 plus 3 is 13. And that's how it works. Okay? Let's do another one. Okay? Problem B, it says 12 times 2 1/4. So the mixed number is going to get split apart to 2 plus 1/4. Very good. So we've got 12 times 2 plus 1/4. Okay? And now you're going to use your distributive property. So that 12 gets multiplied times everything inside the parentheses. Okay? So we've got 12 times 2 is 24. Plus 12 times 4 is 3. I'm sorry, 12 times 1/4 is 3, right? Because 12 divided by 4 is 3. With me? And then 24 plus 3 is 27. Alright, so for those of you who are a little shaky on that 12 times 1/4, let's just write it on the side so you can see what's happening, okay? So we have 12. Let me write it in red. 12 times 1/4, right? So here, if I put this over 1, and then simplify before I multiply, what am I going to end up with? 3 over 1, which is 3. Okay? So why don't you guys try letter C on your own, and then I'll start recording again. This one is different because now we have a decimal in there, but it's not really that different because we can split up the 3 and the 6/10. Is everybody with me?
Yeah.
So this will be 2 times, let me move this down this way, 2 times 3 plus 6/10. Okay? So now you're going to use your distributive property. So 2 times 3 is 6, and 2 times 6/10 is 1.2. And then when you add those together, you get 7.2. All right, for the next example, this is straight distributive property. Okay, so here we want to evaluate 2 times the quantity x plus 3. So with the distributive property, once again, the number on the outside of the parentheses gets multiplied times everything on the inside of the parentheses. Okay? So here we have 2 times x, which is 2x. See, 2 times x. And then we have 2 times 3, which is 6. And that's all there is to it. So let's do example problem D. Here we have 8 times the quantity x plus 3. Okay? Once again, you're going to take that 8, number on the outside of the parentheses, and you're going to distribute it and multiply times everything inside the parentheses. Okay? So here, we're going to have 8 times x plus 8 times 3. So 8 times x is just 8x. Right? And then plus 8 times 3, which is 24. You can, you guys, you can skip this first step and go straight to the 8x plus 24. Okay? If you want to. I'm okay with that. So for letter E, we're going to take that 5 and multiply that times everything inside the parentheses. Okay? So we will have 5 times 9, which is 45, plus 5 times x, which is 5x. And that's your final answer. So go ahead and do example F on your own. So for example F, or for problem F, we're going to take the 2 and we're going to multiply it times everything inside the parentheses. So we're going to have 2 times x plus 2 times 3, which gives us 2x plus 6. So for example 3, it says Fran is making a pair of earrings and a bracelet for 4 friends. Each pair of earrings uses 4.5 centimeters of wire, and each bracelet uses 13 centimeters of wire. Write 2 equivalent expressions, then find how much total wire is needed. So here, how many friends? 4 friends, right? 4 friends. So here, we can say that we need to, let's see, multiply 4 times 4.5 to figure how much wire she needs for the earrings. And we need to multiply 4 times 13 to see how much wire she needs for the bracelets, and then just add them together. Using the distributive property, okay, we can just go ahead and add how much wire she needs for one bracelet and earring set, right? And then multiply it times the 4 friends. So those are the 2 equivalent expressions that you are being asked to write. To check it, you just use your order of operations, and you can see that she needs 70 centimeters of wire. Got it? All right. So let's do this example together. Each day, Martin lifts weights for 10 minutes and runs on the treadmill for 25 minutes. Write 2 equivalent expressions and then find the total minutes that Martin exercises in 7 days. Okay, so you don't have to write the whole thing. We're just going to write our important information, right? What's important here? Lifts weights for 10 minutes.
Runs on a treadmill for 25.
Treadmill for 25. And we're looking for 7 days. See? So, the first expression that we're going to write, okay, I would add the 10 plus 25, right? So we've got 10 plus 25, and we want to do that number of minutes for 7 days, right? So times 7. Oops. Times 7. Is everybody clear? So now, to write the equivalent expression, I can go ahead and take that 7 and distribute it throughout the parentheses. So the equivalent expression would be 7 times 10 7 times 25. And those are the two equivalent expressions. Okay? To check it, we'll just use our order of operation. So here, when I check this, 10 plus 25 is 35. And we're going to multiply that times 7. So, 7 times 35 is?
245.
So, here, we're going to have 245. On the other side, okay, we have 7 times 10 is 70. Plus 7 times 25 is
175.
175, and of course 70 times 175 is 245. So we are correct. So now we're going to factor an expression. We're going to factor an expression. Okay? Please make sure you write down this definition. When numeric or algebraic expressions are written as a product of their factors, the process is called factoring an expression. So this, I equate this to doing a reverse distributive property. Okay? So here, for example, we have, we want to factor 12 plus 8. So we're going to ask ourselves, what is the greatest common factor that I can take out of 12 and 8? 4 is the greatest common factor, right? So that 4 is going to come out. Let's see, if we rewrite this, we have 4 times 3, that's going to give me the 12. And we have 4 times 2, that will give me the 8. You see that? So now, if I take that greatest common factor and pull it out, pull this out and pull that out, that goes in front of the parentheses now. And then whatever is left stays inside the parentheses. So we end up with 4 times 3 plus 2. So, for example H, or for problem H, we have 9 plus 21. Okay, we want to factor 9 plus 21. Please make sure you write your directions, your instructions. So we want to factor 9 plus 21. So we're going to ask ourselves, what is the greatest common factor that can go into 9 and 21? 3, right? So here we're going to rewrite this. The 9 we're going to rewrite as 3 times 3 plus the 21 we will rewrite as 3 times 7. And now we will do the reverse of the distributive property, which is factoring out. So here, the 3's will come out, and we're going to only write that one time on the outside of the parentheses. Okay? So, the 3 comes out, and the rest stays in the parentheses. So we have 3 plus 7. And make your final answer. One more time. Here we have 14 plus 28. What is the greatest common factor of 14 and 28? It can be better than 7. It can be better than 2. 14. Very good. So, 14 will be rewritten as 14 times 1. Right? And then 28 will be rewritten as 14 times 2. And now, the 14 will come out, and that 14 will be written on the outside of the parentheses. So that's going to be 14 here, and then what's left stays inside the parentheses. 1 plus 2. and that is your factored form. You can also think of it as dividing by the greatest common factor. Okay? So here for problem H, here we say, okay, the greatest common factor was 3, right? So the 3 goes outside. What's 9 divided by 3? 3, and there's your 3 right there. What's 21 divided by 3? 7, and there's your 7. You see? Same thing with problem I. Here, the greatest common factor was 14. 14 divided by 14 is 1. And 28 divided by 14 is 2. You got it? All right. Do example J. Do problem J on your own. So for problem J, the greatest common factor there is 8. So here, we have 8 times 10, that's equal to 80. And we have 8 times 7, which is equal to 56. And now we can take the 8 and put that on the outside of the parentheses. So here, the factored form would be 8 times a quantity, 10 plus 7. For example 5, this is the factoring using variables. It's the same process. It is the same process. So here we have 3x plus 15. We want to find out what is the greatest common factor. Okay? The greatest common factor of 3 and 15, of course, is 3. The greatest common factor is 3. So here we've got the 3x we can rewrite as 3 times x. The 15 we can rewrite as 3 times 5. And now the 3's can be taken out. Both of those 3's can be taken out and written on the outside of the parentheses. So here what's left we have is x and 5. So our final expression is 3x plus 15. So let's factor problem K, 16 plus 4x. So there, the greatest common factor with 16 and 4x is 4. So when we rewrite this, we will rewrite as 4 times 4 plus 4 times x. And once again, we're going to take that greatest common factor and pull that out to put in front of the parentheses. So that goes in front of the parentheses, and what's left remains inside the parentheses. So we have 4 plus x remaining. So the factored form of 16 plus 4x is 4 times the quantity 4 plus x. Okay? Now, if you want to check that, you can always just distribute back in, and you should end up with what you started from. So here we've got 4 times 4, 16, plus 4 times x, which is 4x. So we ended up exactly where we started. So, for example L, for problem L, we're looking at the greatest common factor with 7x and 42. So the greatest common factor there is 7. So we will rewrite 7 times x plus 7 times 6. And again, we're going to take that greatest common factor and pull that out to put in front of the parentheses. So the 7 goes in front of the parentheses, and the x plus 6 remains. And that's it. So go ahead and try example problem M on your own. This one's a little different. So for problem M, the greatest common factor between 36x and 30 is 6. So we're going to rewrite the expression as 6 times 6x and plus 6 times 5. So 6 times 6x gives me 36x, and 6 times 5 gives me 30. So now, once again, we're going to take the 6, and that's going to be written on the outside of the parentheses, and whatever is left stays inside the parentheses. So we have 6x plus 5 left inside the parentheses. So our factored form of 36x plus 30 is 6 times the quantity, 6x plus 5.